So let's move on. The next thing that we can see is average speed. Suppose some particle moves with different speeds during different time intervals also. So in order to find the average speed, we can do one thing, that find the total distance covered by the particle in the journey and divided by the total time taken to complete the journey. That is the average speed. And in the same way, we can find the average velocity also, that total displacement divided by total time. Alright, so average means that particular constant value which will attain the same distance in case of speed or same displacement in case of velocity as is done by the actual case. So when an object travels with non-uniform speeds during different time intervals or traveling different segments of path, then ratio of the total distance covered to the total time taken is called the average speed. And similarly, the same definition can be formed for the average velocity. Alright, so let's do some problems based on the calculation of average speed or average velocity. Suppose there is a car which covers 2/5 of the total distance with v1 speed and 3/5 distance with v2. Then what is the average speed? So let x be the total distance. Let x be the total distance. Then 2/5 of the total distance means 2x divided by 5. 2/5 of the total distance the particle covers with speed v1, and the remaining 3/5 distance is covered by the particle with speed v2. So find the average speed. As we know that average speed is equal to total distance divided by total time taken by the particle. So total distance traveled in this case is what? X, that we assumed x is the total distance divided by total time. So here you can see that time taken in during the interval when the particle was moving at speed v1, the time taken will be what? Distance is 2x upon 5 divided by speed is v1. So distance upon speed is the time, and plus in second half of the motion it is 3x divided by 5 into v2. Alright, so here it is what? X upon total time, because 2x by 5 distance is covered with speed v1, so time taken is distance upon speed. So there are two different speeds, but in their intervals these speeds remains constant. So for overall journey we can find the average speed, so that you can easily calculate. So it is, I think, 5 v1 v2 divided by 3 v1 plus 2 v2. So this is the average speed of this particle. So let's move to the next question. If a cyclist takes 1 minute to complete half revolution on a circular path radius 120 meter, what is the average velocity? So cyclist completes half revolution. Cyclist takes 1 minute to complete half revolution on a circular path of radius 120 meter. So radius is 120 meter, and in half revolution it takes 1 minute. So time taken by the particle is 1 minute, that means 60 seconds of course, and the displacement delta x, because we are asked the average velocity. So displacement is the shortest distance between the starting and the final position, and which is in this case equal to the diameter of the circular path. So displacement is 240 meter. That means average velocity becomes delta x divided by delta t. So it is 240 divided by 60. So it is 4 meter per second. So average velocity of the particle of the cyclist will be 4 meter per second in this interval of motion. If a particle travels a linear distance at a speed v1 and comes back along the same track at a speed v2, then its average speed is arithmetic mean this. So let's find out which one is the correct option. So first, since the three options are based on the average speed, so let's find the average speed. So particle, suppose x is the length of the path from starting point to the final point, the distance is x. So this particular particle travels with the speed v1 and then comes back along the same track with the speed v2. So total distance covered will be what? 2x divided by total time taken will be x upon v1 plus x upon v2, because it returns with v2 speed. v2 velocity. So yeah, speed. So it becomes what? 2 v1 v2 over v1 plus v2. So I think option C is the correct option, and the fourth option is velocity is 0. Its velocity, in fact, velocity means it appears that it's talking about the instantaneous velocity, because the word average is not being used. If it was the case that average velocity, suppose it is said that average velocity of the particle for the complete duration is 0, then we would have marked it correct. Alright? But if you just say in a plain way that velocity is 0, no, it's not that, because velocity is never 0. At any point of time, velocity is not 0. But overall average velocity is 0. That I agree. Alright. A car covers the first half of the distance between two places at a speed of 40 km per hour and second half at 60 km per hour, which means suppose the path length is x, then half path length is x by 2, another half is x by 2. This is the starting position and this is the final position. Car travels the first half of the distance between two places at a speed of 40 km per hour. So this half is covered with 40 km per hour and second half is covered with 60 km per hour. The average speed of the car is. So we know that average speed means total distance covered by the body divided by total time. So here suppose x kilometer is the distance between the starting and the final position, and the car travels with 40 km per hour in half the distance, so x by 2 distance, so time taken will be x upon 2 divided by 40. So this much hours will be taken by the car to cover this half distance, and the remaining half distance is covered with 60 km per hour. So average speed becomes total distance covered divided by the total time. So it is equal to 2 into 40 into 60 divided by 60 plus 40. I have taken 2 into 40 into 60 as LCM, so which jumps to the numerator. X has got cancelled. So it is 2 times 40, 60 divided by 100. So it is like that. So it is 48 km per hour. So average speed of the car in this given motion is 48 km per hour. So option B will be the correct option. A particle covers 1/4 of the total distance at a speed of 20 km per hour. So let us suppose x is the total distance. So x by 4 distance is covered with a speed of 20 km per hour. X by 4 distance is covered with this speed, and half the distance, 1 by 2 of the total distance, means x by 2. X by 2 is covered with 40 km per hour, and 1/6 of the distance means x by 6 of the distance is covered with 10 km per hour, and then remaining 1 by 12th of the distance at a speed of 30 km per hour. Alright, so total distance that we have assumed is x, and these different portions of the path are covered with different speeds. So we are here to calculate the average speed of the particle. So average speed becomes V average equal to total distance divided by total time. So total time, so for first one, x by 4 into 20 plus, for the second one, x by 2 into 40 and plus x by 6 of the distance is covered with 10 km per hour, and plus x divided by 12 into 30 km per hour. So this way we can calculate the average speed of the particle. So here you can do the calculation on your own. I am quite confident. So just solve it later on. Alright.